Assalamu alaikum. I welcome you all to a new lecture in NS224 numerical analysis. This is Syed Ibrahim, your numerical analysis teacher. In today's lecture, we are going to discuss the LU factorization of a matrix. So we can factorize a matrix into a lower and upper triangular matrix because as for the solving the system of equation and of the form X is equal to B, so we can factorize a matrix A into the product of matrices that are easier to manipulate the solution for the system X is equal to B. So we consider A is equal to L and U, where L represent a lower triangular matrix and U represent an upper triangular matrix. Previously, we have learned at FSC level that the lower triangular matrices are those matrices in which above the main diagonal all the entries are zero, and the upper triangular are matrices of the upper triangular are those matrices in which the below the main diagonal all the entries are zero. This is an example of a 4 cross 4 lower and upper triangular matrices. So we can decompose uh, a matrix A by different three methods. There are many other methods, but in your course, these three methods are included. The first one method is called Doolittle's method, in which the main diagonal of a lower triangular matrix, all the entries are in the lower triangular matrix on the main diagonal is 1, and the other all entries are variable. It may be 1, 2, 3, 4, 5. It may be anything. But on the main diagonal of a lower triangular matrix, there must be 1 in a Doolittle method. And the Crout's method, we can decompose a matrix A by using Crout's method into a lower and upper triangular matrix. And in a Crout's method, the main diagonal entries of the upper triangular matrix will be 1. And also in the next lecture, we will discuss the Julaski's method, through which also we can decompose a matrix A into the lower and upper triangular matrix. And in the Julaski method, the main diagonal entries of lower and upper triangular are the same. So let us discuss the Doolittle's method. We will discuss the Doolittle start the discussion or discussion from the Doolittle method. How can we decompose a matrix A through Doolittle method? Let us see. So if we have a matrix A which is of dimension n cross n, so we assume that an LU decomposition of matrix A exists. When we match the entries of A with the product of the LU, the lower and upper triangular matrices, then we find the values of the lower triangular entries and the upper triangular matrix. And when we substitute it in the lower and upper triangular matrices, we get the decomposition of matrix A. So as the lower triangular matrix, I have considered a 3 cross 3 lower and upper triangular matrix. The same procedure will be used for 4 cross 4 and 5 cross 5 matrix, but through 3 cross 3 matrix we will discuss the procedure how can we decompose a matrix A through Doolittle methods. So let us see. So first you need to consider the LU factorization of matrix A, that there exists the LU factorization of the matrix A, as I have right here, and you can write here L21, L31 also, but I have right here M21, M31, so you can change it. And for the upper triangular matrix U11, so you need to write two matrices, the lower and the upper triangular matrix, and consider it that we can write the matrix A in the product of lower and upper triangular matrix. And then after multiplying these two lower and upper triangular matrix, we get that one resultant matrix. and by comparing the entries of these two equivalent matrices, because we have considered A is equal to the product of lower and upper triangular matrix, so this matrix and this matrix are equivalent through our consideration. So, by the definition of two equal matrices, uh, two matrices are said to be equal if and only if all the entries and the order of the matrices are the same. So u11 will be equal to a11, u12 will be equal to a12, and u13 will be equal to a13. In the same way, m21 u11 will be equal to a21. So we can compare it by multiplying the first row of the lower triangular matrix with the first column of the upper triangular matrix and the second column of the upper triangular matrix and the third column of the upper triangular matrix, we get u11, u12, the first row of this resultant matrix. And by comparing this resultant matrix with matrix A, we get a11 is equal to u11, a12 is equal to u12, a13 is equal to u13. Now, by multiplying the second row of the lower triangular matrix with the first column, the second column with the third column, we get the second row of this resultant matrix. And by comparing these values with this, we get a21 is equal to m21 u11, a22 is equal to m21 u12 plus u22, and m23 is equal to m21 and u13 plus u23. And in the same way, for the third column, for the third row of this resultant matrix, we multiply the third row of the lower triangular matrix with the first column, with the second column, and with the third column, and we get all these results. Let us consider we have a matrix A is equal to 2, 3, 2, 1, 3, 2, 3, 4, 1. So, as we have considered previously, that you need to assume that we can decompose these matrices to LU factorization. So, I assume that A is equal to this resultant matrix, and after this assumption, U11 will be equal to 2, u12 will be equal to 3, and 2 is equal to u13. And in the same way, now m21 and u11 is equal to 1. Also, we have found the value of u11 previously. So by putting this value at the place of u11, we will get the value of m21. By shifting this 2 to the left side, we will get m21 is equal to 0.5402. And in the same way, now we know the value of m21 and the value of u12 from here. By substituting the value of m21 and u12 and putting this equal to 3, we will get the value of m21, and in the same way we can find the value of u23 from here. By after finding all these values, we will substitute all these values in the lower and upper triangular matrix, as I have right here the decomposition of A in terms of lower and upper triangular matrix. So through Doolittle method, we can decompose a matrix in this way. I will share uh, many other examples in through these Doolittle methods. So let us see how can we decompose a matrix through Crout's method. In the Crout's method, as we have defined that the in the upper triangular matrix in the Crout's method, the main diagonal will be 1, and after multiplying these lower and upper triangular matrix, we will get this resultant matrix. So, by comparing the Doolittle methods and in the Crout's method, in the Doolittle method, the first row represent the first row of the upper triangular matrix, and in the Crout's method, the first column here, the first column of the resultant matrix represent the first column of the lower triangular matrix. So after getting these values, we will compare this resultant matrix with this matrix. So here a11 will be equal to m11, a12 will be equal to m11u12, and a13 will be equal to m11u13. And in the same way, by multiplying the second row with the first, second, and third column of the lower triangular matrix with the upper triangular matrix, we will get these comparison that m21 is equal to a12 and a22 is equal to this value and a23 is equal to this value. And in the same way, we can find all the values of the lower and upper triangular matrix with the help of this given matrix. So let us see how to decompose a matrix A through Crout's method. If we need to find the LU factorization of a matrix or the solution here, we need to solve the system by LU factorization. Let us see how to solve this system by Crout's method, and also in the same way as we have discussed the Doolittle's method. So first we need to find the matrix form of this system. So we can write this system in that shape in the matrix form. We can convert it to the matrix form where this matrix is called the coefficient matrix. This matrix is called the variable matrix, and this matrix is called the matrix B, the resultant matrix. So previously we have discussed that we need to assume that there exists the LU factorization of the coefficient matrix A. So I have write it here, the decomposition of the Crout's method. If you write here the decomposition of the Doolittle method, then the method is called the Doolittle's method, and if you write the decomposition of the Crout's method, then the method is called the Crout's method. Now, after multiplying these lower and upper triangular matrix, we will compare these results with the coefficient matrix. So here m11 will be equal to 2, m21 will be equal to -1, and m31 will be equal to 4. And also m11 m12 is equal to -1.5, as we have find the value of m11. So we will substitute the value of m11, which is 2. After substituting the value of m11, we will shift this 2 to the right side, and after dividing -1.5 by 2, we will get -0.75. Also, we will compare this value with the coefficient matrix with this value m11 m13 is equal to 1, and as we know the value of m11, after substituting the value of m11, which is 2, and shifting to the right side, we will get u13 is equal to 0.5. And in the same way, by comparing this value with this, we will get m21 u12 plus m22 is equal to 0. And after substituting the values of m21 and u12 and shifting to the right side, we will get the value of m22, and in the same way we will get all the values of the lower and upper triangular matrix, which is u23 is equal to -3.333 and 32 is equal to -1.5 and 33 is equal to -1.9995. And after finding all these values of the lower and upper triangular matrix M11, M21, M22, M31, M32, M33, and U12, U13, U23, we will substitute all these values in the lower and upper triangular matrix. So till now we have learned how to decompose a coefficient matrix into the lower and upper triangular, the product of lower and upper triangular matrix through Crout's method and through Doolittle's method. And from here onward, the method is the same for the Crout's and Doolittle methods. So let us see how to find the solution of the system after decomposing the coefficient matrix. So to find the solution X is equal to B after decomposing matrix A into LU factorization, we will write the this equation as x is equal to b as L into ux, L into ux, because we have write this represent the this equation x is equal to b, and by replacing a by lu we will get lu into x is equal to b. Also we can write it like that, L into ux is equal to b. Then we will consider that ux is equal to y. Then we have ly is equal to b, where y is equal to y1, y2 and y3. And after writing this, we will find the values of y1, y2 and y3. And after that, we will put these values in this equation ux is equal to y, and we will get the values of y. Let us see how to substitute, how to perform all these processes in this system, as we have decomposed the matrix A into LU factorization. So let us see. Let us then you after decomposing the matrix A into lower and upper, the product of lower and upper triangular matrix, you will consider that u x is equal to y, as I have write the equation x is equal to b here, ly is equal to b. So then we will write the lower triangular matrix, the y variable matrix and the resultant matrix b. Now, as we have convert the system of equation into a matrix form. Also, we can convert this matrix form into the system of equation. By converting this equation into the system, we will get 2y1 plus 0y2 plus 0y3 is equal to 1. Now, from where we will get the value of y1. So from this first row of this system, x is equal to b, ly is equal to b, we will get 2y1 is equal to 1, which implies that the value of y1 is 0.5. From the second row of this system, ly is equal to b, we will get minus y1 minus 0.75 y2 and plus 0 y3. We don't need to write the 0 multiple value. So we will get minus y1 minus 0.75 y2 by putting the value of y1, which is 0.5, and shifting to the right side, and after the algebra we will get y2 is equal to minus 4.6666, and in the same way from the third row of this system we will get the value of y3. So from the third row we will write 4y1 minus 1.5 y2 minus 1.9995 y3 is equal to minus 1. So as we have converted a system to the matrix form, also we can convert the matrix form to a system. So after getting these values of y1, y2, y3, we will substitute all these values in the ux is equal to y. Now you need to write the upper triangular matrix, because we have considered here the ux is equal to y. So we will put the value of the values of y to the right side, and the x matrix and the upper triangular matrix. And in this upper triangular matrix, x variable matrix and y matrix, we will start from the third row, because here we have find the values of y1, y2, y3 in the ascending order, because we have the lower triangular matrix multiple with the unknown values, and now here we have the upper triangular matrix with the unknown values. So we will start from here and go upward. Now, so from the third row we have x3 is equal to, we will convert this matrix into the equation form. So we will get x3 is equal to 5.002, and from row second we will get x2 minus 3.333 x3 is equal to minus 4.666, and after substituting the value of x3 here and shifting this value to the right side, we will get the value of x2. And from the first row we will get x1 minus 0.75 x2 plus 0.5 x3 is equal to 0.5, and after substituting the value of x2 and x3 here, we will get the value of x1 is equal to 7.002. So hence the solution for the system is x1 is equal to 7.002, x2 is equal to 12.005, and x3 is equal to 5.002. So till now we have discussed how to decompose a matrix A through Doolittle's method and Crout's method to the product of lower and upper triangular matrix. And then after converting the matrix to the lower and upper triangular matrix, the solution procedure is the same for both the methods. So after converting the matrix, you need to consider that the product of uh, the product ux is equal to y. Then you will find the value of y1, y2, y3, and after putting all these values in this equation ux is equal to y, you will get the values of x1, x2, and x3, which is the solution for the system of linear equation. So you need to remember that tell uh, decomposition of the matrix both the methods are different, and after decomposing the matrix into the product of lower and upper triangular matrix, the procedure for finding the solution is the same. So please download the handwritten notes also, and we will discuss in the next lecture that how to decompose the matrix A into the product of a lower and upper triangular matrix through Cholesky method. So see you in next lecture. Thank you for watching this.